This video is an introduction to amplifiers. It corresponds to sections 18.1 and 18.2.1 of Applied Analog Electronics. Now, when we talk about amplifiers in this course, we are talking about something that takes an electrical signal and converts it to a different electrical signal. Quite often, these will be taking a voltage signal in and putting a voltage signal out. In fact, if we use amplifier without any modifier, we generally do mean a voltage amplifier. There are also other possibilities. You can take a current in and put a current out. That's called a current amplifier. You can take a current in and put a voltage out. That's called a transimpedance amplifier. Or you can take a voltage in and put a current out. That's a transconductance amplifier. We're mainly going to be dealing with voltage amplifiers, though we will look also at transimpedance amplifiers because those turn out to be quite useful for bioengineers. Alright, so let's take a look at some of the symbols we use. When we're working in a block diagram, we represent an amplifier as a triangle, the input on the left, output on the right, and that's usually all we need. Quite often we will associate with this amplifier some properties. Usually the most important one is the gain. And these signals that we have on the input and the output here, if they're voltages, they can be either single-ended or differential voltages. What's the difference here? Voltages, as we know, are always a difference in potential between two different points, two different nodes in our circuit. When we're doing a differential one, we actually have two wires for the signal, basically a positive wire and a negative wire, and the differential voltage is the difference in voltage between those two wires. When we have a single-ended signal, we are doing it with respect to some defined point in our system. And there's two possibilities. One is that it can be with respect to ground, and that's a convenient one because then you can talk about just what's the voltage at this point. But when we're dealing, as we do in this class, with a single power supply, ground is not a very convenient voltage reference because you can never go below it in your system. So we often have a special voltage which we call Vref, which is the reference voltage for the single-ended signals. And if you've got a dual power supply where you have both a positive and a negative power supply, Vref and ground are usually treated as the same. So Vref is sometimes referred to as the virtual ground. It's the voltage that we're going to compare other voltages to when we're looking at single-ended one-wire signals. Okay, so this is the block diagram. What's the schematic symbol? Well, we have several slight variants on the schematic symbol depending on whether we've got one wire or two wires that we're dealing with. One very common symbol that we'll use over and over in this class has got two inputs and an output. This is a differential amplifier. And we will have several different sorts of differential amplifiers in this class. Unfortunately, they all use the same symbol. So you have to know from context what sort of differential amplifier is meant, because we will use this for op amps. We will use it for instrumentation amps. We'll use it for comparators. They're all rather different circuits, but they all share this common differential amplifier symbol. Sometimes the differential amplifier will have an extra input to give the reference voltage. Because we've got a single wire coming out here, it's got to be with respect to something. And that, what it's with respect to, is sometimes taken in as an extra input to the amplifier. We'll see that on instrumentation amplifiers particularly. Alright, so I said that the most important property in a block diagram is the gain. What is the gain of an amplifier? Well, gain for an amplifier is like sensitivity for a sensor. It's the derivative of the output with respect to the input. So the slope of a line, that if you draw an amplifier gain, it should look something like this, and the slope of that line is the gain. So how steep it is, that's the gain. Now here I've drawn it as going through 0, 0, and that's dependent on exactly what we mean here by 0. So this would be, on the output, this would be V out is equal to V ref. That's when the signal is 0, because that's what we mean when we say it's with respect to V ref. We want to treat a 0 input as producing V ref at the output. And if we're talking about a differential signal here, what's on this axis might very well be V plus minus V minus, the difference between those two wires here. Okay, so we expect to see a nice straight line like this. That's a linear amplifier. And most of this class, because it's about analog electronics, will be about linear amplifiers. We do also, however, deal with what are called digital amplifiers, where the gain is so high that basically the output is either high or low, and you don't get intermediate voltages. We will use that for comparators, for example. All right. What else do we need to know? Lots of things, but the basics here are the gain. The definition of the gain is the derivative here. Oh, let's write it down for a differential amplifier. What would be the gain equation? We would have V out minus V ref, that is the output voltage, divided by the difference of the two inputs, that's the differential input voltage, that's the gain. And notice that here I'm not using derivatives. That's because I'm assuming that the amplifier is a nice straight line. The output is always going to have the same slope here, and so if you just take V out minus V ref, that's how far up we are here. This is V out, so V out minus V ref divided by the difference between V plus and V minus is going to give us the slope. All right, that's enough for this first video.